So question here, do you have any good stories about working with or learning with Dick Feynman, Paul Dirac, or other physicists? Well, gosh, I started doing physics when I was kind of a kid, and started publishing papers and things when I was like 14, 15 years old or something, a long, long time ago, mid-1970s. And I interact with lots of physicists. One of the things about the physics community is it's very international. And so even if you're just a kid, hanging out in Oxford, for example, you fairly quickly sort of get to meet lots of the movers and shakers of physics, because it's a community that's both small enough and mixing enough that happens. I have to say one thing that is a regret on my part. I think it was 1986. I must have been 16 years old. Somebody says, "Oh, Werner Heisenberg is giving a talk in Cambridge. You should go listen to it." And he always likes to meet, young'uns, and you should meet him. And I was like, I don't know. He's an old guy. I don't know what I'm going to be able to learn from him. And I didn't bother to take the train ride, a couple of hour train ride to do that. Big mistake. I have to say that mistake was a sort of a pre-web kind of mistake, because I didn't know that much about Heisenberg. I mean, I knew some of his work in quantum mechanics and so on. I knew things that his name was attached to and so on, but I didn't really know what he'd done in the years after the 1940s, actually. And he did, in fact, a lot of sort of organizing of German science, but he also pursued a kind of unified field theory and so on, which I might have thought wasn't interesting. And at the time, I probably thought wasn't interesting because I was a kind of I know quantum field theory is going to make everything work kind of kid, because quantum field theory was the big thing, the analog of modern LLMs and so on, was in the mid-1970s was quantum field theory. That was the sort of the new game in town, or at least newly working game in town, that looked like it was going to take one a long way. And it did take one a certain distance, although by the beginning of the 80s, sort of the most obvious places it might take one, it had taken one already. But in any case, had I really known what I know now about Heisenberg, I absolutely would have said, sure, I want to meet this guy and learn about kind of his ideas about sort of the relationships between things like fluid turbulence, which he had studied quite a bit, and fundamental physics, which is now something I'm quite curious about. But anyway, so that was a goof on my part. But it's always funny to see so many names in physics, for example, because it was sort of a golden age of physics that, there'd been a golden age in the 1920s to 1940s, and many of those people were still alive when I was a kid, and I met many of them. And it's sort of a funny thing when people kind of say, they mention some name, and I remember, oh yeah, I knew that person, and I know something of the personality of that person, and it's so strange to have them be a disembodied name with disembodied ideas, so to speak. And I remember Stan Ulam, who was a person who worked on cellular automata. He also worked on nuclear weapons, and he also worked on a bunch of pure mathematics. But I knew him. And actually, this is something he said, talking about John von Neumann, who he had known quite well, but who had died in the mid-1950s before I was born. So I certainly hadn't met him. But Stan Ulam was saying, I suppose to you, John von Neumann seems like some distant figure, just like Gauss seems to me. But to him, to Stan Ulam, John von Neumann was this jolly fellow who he had known quite well for many years. And that's kind of how I feel about all these sort of disembodied names of physics and so on that one hears from young people. It's like people will bring up some particular person. It's like, yeah, I knew that person. They were kind of a crazy guy and always doing wild things and so on. And for them, it's just a name connected to some ideas, possibly, and the way these things work in the attributions of science. It's sometimes not the right name attached to the right thing, but be that as it may. But specifically, it was asked about Feynman and Dirac. I didn't know Paul Dirac. I could have known Paul Dirac. He spent most of his life in Cambridge. I didn't meet him there. I could have done. He moved when he retired. He moved to Florida. Apparently, he opened up a lot at that time. I know that in his earlier years, at least according to Dick Feynman, who I knew quite well, Paul Dirac was a very monosyllabic person. He was, he would say very little, be very minimal. Apparently, he opened up a bit more in his later years. I remember a person who was a high school teacher of mine named Norman Routledge, who had also been a friend of Alan Turing's, actually, and who in subsequent years I learned quite a bit about Alan Turing from. But anyway, Norman Routledge, who was a rather colorful character, had known Paul Dirac's son quite well in Cambridge, and apparently quite often visited the Dirac household, and sort of supported this idea that Paul Dirac was very, very taciturn and monosyllabic, but apparently had many kinds of mathematical toys which he would kind of play with, which maybe comes with the territory, but often doesn't. I mean, I certainly am not that into, even though I like mathematics and the foundations of mathematics and so on, actual mathematical, toys and puzzles and things, I'm not really that into those things. And I, if you give me the cube that comes apart in a weird way, I won't be a top performer in putting it back together again. In terms of, well, gosh, let's see, so many physicists and so on. Yeah, I suppose I can mention a few things about Dick Feynman. I have to say, when I remember, I went to Caltech in when was it, 1978, and as a young lad, and I remember that the two sort of most famous physicists who were there were Dick Feynman and Murray Gell-Mann. Murray Gell-Mann was particularly famous for having invented quarks, but I always found it. Well, I got to know them both. They were not big fans of each other, and I would hear from each of them sort of snide comments about the other, so to speak. But with Dick Feynman, one of the funny things about Dick Feynman is that his sort of great reputation in physics is kind of as an intuitive thinker. But I think his greatest real skill was as a calculator of things. But somehow it takes intuition to calculate right. And what would happen, in my working with him, he would do things where he would do some big, long calculation, and I would just use a computer to try and do some similar sort of calculation. And, the thing that to me was remarkable was he would actually get the right answer. And I would usually say, I don't really understand your calculation. He would say, I don't understand your computation. And he was quite aggressive, really. And we'd have quite a spirited discussion about it. That's another thing that was sort of a paradox for Dick Feynman, was that he had this reputation of being this kind of cheerful, playful, upbeat fellow. And that had the downside that when he would actually interact with people and get frustrated because they weren't understanding what he was talking about, or he wasn't understanding what they were talking about, and he would get sort of aggressive, people would be horrified, because it's like, but aren't you the kind of playful, upbeat kind of chap? That was sort of a persona that developed partly from the books that he wrote with Ralph Layton and so on, about some kind of fun stories about his life and so on. But so it was sort of a downer to have a reputation for being sort of Mr. Nice Guy, but just be Mr. Regular Guy in reality. That sort of didn't work out so well. It's sort of better to have a reputation for being terrible, but actually be perfectly reasonable in person. People seem to have a better response to that. But I think, for me, the thing that was always remarkable about Feynman was that he would calculate things and get the right answer. But he always thought that was easy. So then he would figure out, once he got an answer that he was fairly confident about, he would then figure out some intuitive way to make it obvious that you would get that answer. But because he sort of thought, oh, it's easy to do the calculation, he would throw away the calculation, and he would tell people only about kind of the intuitive steps that he'd taken to get to that answer. And that was very confusing for people because it's like, but that's an amazing piece of intuition that you have to get you to that answer. How could you know that that would be right? Well, the real reason he knew it could be right was because he'd done all these calculations. It was not trivial to get the calculations right because calculations can so easily go astray, but there's a different kind of intuition you need to have calculations go right than to necessarily go to have sort of the physics steps go right. But so that was sort of one anomaly with Dick Feynman. I have to say, in those years, I was always doing computer calculations of things, and it was I suppose maybe I was guilty of the same kind of issue because I would just put down the answers from my computer calculations, and people would say, "How on earth did you get that answer?" And they sort of made the assumption that I had some great skill, more like Feynman's skill of calculating things, which I absolutely do not. Instead, it was sort of there was just the mystery computer inside, so to speak. You know, I think gosh, I did quite a bit of work with Dick Feynman. I mean, I think I knew him when I was at Caltech. He was well, he was quite interested in the things I was trying to do with computers, and he offered many suggestions in the development of SMP, which was kind of a forerunner of mathematical morphem language that I developed back in 1979 to 1981. I think his suggestions were often, to my mind, rather hacky. I mean, he was like, this is how I calculate this or that thing. You should make a computer do it that way. And I suppose what I would say now is, well, maybe you can make that work, but that's not a thing that can sort of be industrialized to make a computer do it. That's a Dick Feynman special, so to speak, rather than a thing that is can readily be turned into sort of a clean algorithm. And I think he never really got the idea of sort of language design and sort of making something that was intended for other people to use. Just wasn't something he'd ever thought about particularly. You know, there were, I mean, there's a whole years and years of all sorts of strange incidents with Dick Feynman. I think one of the things that I didn't really learn, but I should have learned is, you know, when you're going to a talk that might not be so good, don't sit next to Dick Feynman, because he had a terrible habit of sort of figuring out or coming up with something to say that was like you know, a terrible put down, so to speak. And somehow I kind of by being the person who was sitting next to him, I somehow often got tarred with the same brush. I remember one terrible time of some talk, it was about nuclear physics, and Dick Feynman kind of said, "So you mean what you're really trying to say is that when you collide two cream puffs, you throw two cream puffs at each other, they go splat," which was not actually a bad summary of the talk that had been given, but that was somehow I don't know how I sort of got tarred with that particular brush. Certainly, I was, you know, the 20-year-old me was not responsible for what the 60-something-year-old Dick Feynman was doing. I suppose well, another thing that happened, so I suppose I was a bit involved because I used to organize the theoretical physics seminars at Caltech. And so I would typically be the person who was inviting many of the speakers. And I suppose in that sense, I was involved. And for a while, Dick Feynman never what can I say? I mean, he was in many ways a very responsible and reasonable human being, but he would also have his kind of playful side, which he didn't always quite know what that was, how that would be perceived by people. And I remember in these seminars, he developed this kind of competition with me. I don't know why. Well, I guess he saw me as a fun young foil for his thinking, but he would sort of have this competition of who could figure out the fatal flaw in the talk that was being given first, and he had this habit of drumming his fingers on the table, and then he would kind of look over and sort of wink that, you know, he figured something out. And I remember one time actually that happened. I think actually that time I figured something out. Yes, it must. Which actually turned into a fairly interesting paper about, it was a talk about kind of the standard model of particle physics. And I kind of realized at some point that if you took this in the way this person was saying, that the vacuum for the universe would become unstable, which is probably a bad thing. And in fact, that turned into an interesting paper that I wrote with David Politzer, another physicist who years later finally got his Nobel Prize for discovering asymptotic freedom in QCD. We ended up writing a paper about sort of the constraints on particles associated with the vacuum going unstable. But that was something I figured out as a result of being kind of induced by Dick Feynman to kind of go look for the fatal flaw. I have to say the person who, well, it's just one of those things where it was probably not the best kind of not the best dynamic of looking for the fatal flaw, so to speak. Not my fault. I realize in a different domain, you know, Dick Feynman and I were both consultants at a company called Thinking Machines Corporation in Boston. This is in the kind of 1984, 85, 86 timeframe. It was a company that was sort of making a push to make a massively parallel computer, a computer with 64,000 separate processors that could do some very interesting things on the kind of science I was interested in, although they tried to push it in a more generic computing direction, which didn't work very well. But we were both consultants there, and Feynman had a habit of saying, let's hide away and do physics, which we did to some extent. But I also was very vocal in saying, the strategy this company is adopting is just not right. It's going to fail. They keep on, you know, following the strategy, it's going to fail. And he was like, we're just physicists, you know, let these people run their own company, so to speak. They know what they're doing. As it turns out, the company did fail, but more or less the reasons that I predicted, which was a big shame. But that was, Feynman had sort of convinced himself that physics was what he should be doing, physics and nothing but physics. Although he was always interested he was kind of broadly interested in a kind of open-minded person. And he certainly, he kind of liked sort of wild thinkers. And he got quite involved with a bunch of kind of the new age folk and so on. I think he found academics kind of dull in many ways, because he found that they had these particular lines of thinking about things, and it was just like not as colorful and not as innovative as the kinds of things he liked to think about. So he would tend to sort of hang out with these weird characters and so on, or at least weird from the point of view of sort of straight-laced academics and such like. He somehow, when it came to more administrative things, you know, Feynman was always like, I don't do any of that stuff, he would say. And he was convinced that he really was not good at it, which I don't think was really true. I think he had experience with two categories of sort of administrative types of situations, which were kind of the worst cases. One was university administration, and the other was publishing companies. And he had terrible things to say about both of them. And I think in many respects, deservedly so, because those are just areas where they're just not very efficient kinds of places where management and governance happens. You know, I remember him saying he had a book he wrote about QED, quantum electrodynamics, and he was telling me about this publisher that he was dealing with who was wanted to put this cover illustration on this picture, and he'd explained to them that this cover illustration was specifically not an example of QED. I think it was a kind of an oil slick with a kind of Newton fringes and things in it. And I don't know what, I mean, I don't think it was a particularly wonderful picture, but it wasn't, I didn't think it was a particularly, it's got to have some cover illustration, and QED is quite an abstract thing, but Feynman was very kind of wound up about the fact that these publishers just didn't understand anything and were sort of pushing for things that made no sense. And I think it was interesting that in a sense he had the point of view that sort of he didn't really believe in experts. He always believed you should figure things out from first principles yourself, and that had worked very well for him in many domains, but not perhaps in some others. I mean, for example, in these domains of kind of the management of things in the world, I have to say I've always taken the point of view, maybe I partly learned from him, or maybe partly he found it amusing to interact with me because I had the same instincts, that I tend to think about things in sort of a foundational way from first principles, and I've also applied that idea to companies and management and so on, and it's worked quite well. And I think he could perfectly well have done the same thing, but for whatever reason had sort of convinced himself that he just wasn't, that it was just an ugly area not to get involved with. But I think he had those two particular examples, which were particularly bad examples of those dynamics. I think I could tell many other stories about Dick Feynman, about all sorts of different kinds of things. I mean, oh gosh, I don't know. Lots of interactions that we had together with lots of kinds of situations of curious things and people and so on, and his reactions to them. But I don't know. I could yak on about physicists I've known for a long time. Let's see. Yeah, so there's a question here from Ronin. Is Dick Feynman the smartest person you've met or worked with in real life? I don't know. I don't ever consider it to be sort of a linear scale of smartness. I think I mean, there are people who are very quick. There are people who are very knowledgeable. There are people who one is on the same wavelength as, and one can understand them very well. These are all different dimensions. I mean, one thing about Dick Feynman was in his kind of seeking of first principles and sort of foundational thinking, he didn't like to know stuff. He liked to figure stuff out. And sometimes I think in my own efforts in science, knowing a bunch of stuff is really useful. And I think Feynman perhaps handicapped himself a bit in not choosing to know more stuff. Now, I think he didn't find it that exciting to read lots of things that people had written, and I think he always felt that it was kind of cramping his style to kind of know too much about what had gone before. And I kind of agree with that at some level. I mean, if you get too sort of, if you drown too much in what is known before, and particularly what people's prejudices were before, you can end up being like, I'll never be able to figure this out. Oh, there's 10,000 papers about this. I've got to read them all before I figure anything out. That's definitely a thing that he and I, in different ways, sort of resist. I think, in terms of if you sort of, would talk to Dick Feynman about something, he was good at drilling down to sort of get to the what's the point question. I think both at sort of a meta level of knowing that was a thing you could do, and at the level of sort of asking the right questions to get to the point. It's certainly not the only person I've known who does that. I tried to do that myself. Another one who did that pretty well was Steve Jobs, in a very different domain of kind of the what's the point question. Let's try and drill down and see what's really going on. It's not something. It's something where it's not a thing where it's sort of instant gratification of, yes, this is instantly figuring something out. It tends to be more of a, there's this question, then this question, then this question. It often feels almost Socratic that, you're asking a bunch of questions, and then in the end, something gets figured out. And I suppose that was a thing that that was good at. It's a funny thing because I've known a lot of very bright, capable, and accomplished people, and it's very hard to put all these people on any kind of scale. I think that they have each their particular attributes. I mean, as I say, Feynman very much in the drill down until you get to the foundations of things, and that's possible, and that you can figure stuff out. You don't need sort of an expert to tell you the answer. I think Murray Gell-Mann, who I mentioned earlier, was sort of almost the exact opposite. He was like, let me do the erudition, let me learn all this stuff, let me be very sort of be able to trot out these things, and let me operate. Dick Feynman was very much like, just give me the simple explanation of something. Murray was much more of a, let me come up with elaborate mathematical structures that can let me talk about this particular kind of thing. I would say that, where'd they get in the end? Well, Murray Gell-Mann invented quarks. That was a big deal. He was very much involved in the invention of QCD. It was a big deal, and of gauge theories and so on. So, he didn't do so badly. Dick Feynman, if you look at his sort of science accomplishments, one of the ones that was a great accomplishment in sort of the historical greatest accomplishment was the idea of renormalization in quantum field theory, which he always thought was a total hack. And he it's one of those cases where the thing that you're most known for is the thing you think the least of, so to speak. And the other thing he was much known for in quantum field theory was Feynman diagrams, which are a method of calculating quantum field theory that has been used ever since, so to speak. And he always used to say to me, these Feynman diagrams, they're really dopey, and there's got to be a better way to do this. And I had worked out at some point that if you can make a sort of sequence of Feynman diagrams at successive orders in so-called perturbation theory, and I had worked out at some point that at the kth order in perturbation theory, the rough computational complexity of working out these diagrams was like k factorial to the 5th power. And for some reason, that conversation sort of, I was sort of one of these right by the elevator, and was standing there for like an hour or something talking about this. Because I just worked this out, and he was like, yeah, that just shows these diagrams are kind of a dumb way to work this out. There's got to be a better way to do this. But he never figured it out. I'm excited because I think I actually have a way now in the last couple of months that is a possibility for what sort of is underneath Feynman diagrams, and maybe is a way to actually work these things out. And it's a big shame Dick Feynman isn't around to talk to about that, because he would have had a bunch of good ideas, and he would have been sort of thrilled to even have opened up that possibility, so to speak. It's a funny thing, because people, another thing to say about sort of the smartest person in the room type story is it's sort of a question of what you're applying your talents to. And there are people who have great talents that they apply in some direction that doesn't use their talents. And there are people where you get to a situation where those talents just happen to be the right thing to apply to kind of the things that are on hand, or the things you've exposed yourself to. And I feel like in some of these kinds of things in physics, Feynman was, I'm not sure he always found the right thing to work on. I mean, I remember when I knew him, he had a longtime assistant named Helen Tuck, a rather lovely person, who would say to me every so often, he'd say, you've got to go talk to him. He's working on Mayan hieroglyphs again. He's sort of run out of questions that he wants to work on. And so he's trying to decode Mayan hieroglyphs, which she thought was kind of a beneath his intellectual station, so to speak, to be doing. but I don't think he was not a person who sort of wanted to make grand theories of things. He was much more a person who wanted to kind of take the next intellectual hill. And when he worked on quantum field theory long before I knew him, it was really that question of, okay, we've got quantum electrodynamics. Can we calculate things from it? Okay, let's take the next hill. Let's invent renormalization. Let's invent Feynman diagrams to do those things. It wasn't sort of the big arc of let's find a unified theory of physics. It was more, let's take the next hill and solve what we can solve with quantum field theory. And I think that was, in a sense, perhaps that was a limitation of the sort of level of foundationalness that he was prepared to think at. I mean, it was foundational at the level of particulars, but not foundational at the level of sort of the grand arc of things. I mean, I would say that another thing he tended to do, which is like, just ask the frigging obvious question. Like, he worked on gravity at one point, and it's just like, well, the obvious question is, can you do it like quantum field theory? Okay, well, give it a try. And, then you have to kind of navigate through that to see whether you can make it work. I think well, let's see, I was going to mention other, I mean, this whole question of sort of what should you work on? I don't think that was as much Feynman's kind of strength. And you asked, I think, as I say, his strength was, given a problem, solve it. And whereas other people, their strength is define a direction, invent a whole conceptual framework. Maybe those people are not as good at being able to actually do it, but they're good at kind of defining the outline of what should be done. I have to say, in terms of Dick Feynman and his activities, he used to do a class at Caltech he called Physics X, which was a class where undergraduates could just show up and ask him, I think it was on Friday afternoons, I don't remember, but could ask him random questions about physics. People like me were absolutely barred from showing up at those things. But it is in my efforts doing these live streams and so on, I feel a little bit like I never saw a Physics X, so I don't actually know what happened there. But I kind of feel like I'm probably channeling a little bit of the Dick Feynman tradition of trying to sort of just answer questions. And I have to say, he was, when it came to these sort of general science questions and so on, he was a good explainer, and he was quite good at the sort of, well, I don't know, he certainly was quite interested in kind of these intuitive physics explanations. You have the sprinkler that turns itself around and it's sprinkling out water, and then you put it underwater, what's going to happen to it type thing. And I don't know, I suppose I might downgrade his prowess at those kinds of things, because he always thought that I was good at those things, and I don't think I'm good at those things. So I don't know where that leaves one in kind of the chain of prowess about those kinds of intuitive physics questions. Let's see. Someone's asking, who's the funniest person you've ever met or worked with? Oh boy, I don't really index people that way. For some reason, I'm reminded of this story. I was working with David Pollitt, who I mentioned earlier, on this piece of work that I mentioned earlier about the instability of the vacuum. And David is 10 years older than me. So this was when I was probably 18, maybe he was 28. And it's late in the evening, we're working on something, and David sort of is getting distracted. And I remember he said, he said, I'm thinking about something. I'm wondering whether any of those Scottish tartans are, with sort of crisscross patterns. I wonder when any of them are logarithmically arranged. And I'm like, you're not paying attention. We're trying to solve this physics problem, get back in gear type thing. But in any case, that's not a great example. I'm trying to think. I mean, I've known some. I mean, a lot of scientists. There's a certain diversity of personalities, and some people are very sort of apparently serious. Some people are always making jokes about things. I mean, I'm kind of a chap I know quite well named Predrag Cvetanovich, who's a person who actually worked on Feynman diagrams early in his life, but then has worked on sort of chaos theory and things, is always writing these, doing these things that are kind of, that are sort of humor of a certain kind. I mean, it's always a complicated thing because, people will come up with these sort of rather whimsical kinds of ways to present things, and maybe they'll take them seriously, maybe they won't. To mention a person I already mentioned, Murray Gell-Mann. So he was not the humorist, really not the humorist. He was a kind of a take yourself kind of seriously kind of person, and he would make these kind of very erudite and not very, sort of maybe erudite humor, but at the very tame erudite humor. But yet he was famous for having invented, for example, the concept of strangeness when applied to particles in the 1950s was kind of a thing that solved some problems in particle physics to invent this concept of strangeness for particles, strangeness -1, strangeness 0, et cetera, which is a very whimsical term, even from a very sort of apparently serious-minded, erudite kind of person. And then, well, he invented the word quark. Dick Feynman told me his version of the story of the invention of the word quark, which was that he talked to Murray some Friday or something, and Murray was talking about these sort of constituents of protons and things like that, and Feynman had sort of said, well, you got to have some name for these things. Why don't we just call them quacks? And apparently then okay, fine. And then Murray went off for the weekend and then came back on Monday morning and said, I found this word in James Joyce in Finnegan's Wake or something. I found this word quark. This is this sort of validates the erudition necessary to use this weird sound as the name of a thing. And now, of course, they're quark everything's everywhere. But it's kind of a funny thing because it's sort of both the, there's whimsy coming out of a person who is, has a very serious affect. And then there are, sometimes there are people who are very playful in the way they present things, but yet the things they produce are kind of very sort of on the straight and narrow. Let's see. Let's see. Well, G is commenting, some people crack nuts, other people find nuts to crack as they map a new space. Who comes to mind as examples of these types? I mean, there's so many different kinds of things people do. I mean, to take, I don't know, let's take Kurt Gödel and Alan Turing as examples. Alan Turing was very much a take the next hill kind of intellect person. He worked on Turing machines, he worked on code breaking, he worked on theoretical biology, he worked on all kinds of things. And at each step, he was kind of taking the next hill. He sort of did it, he made a contribution, he got out. And that was, whereas Kurt Gödel, I think, had much more of a kind of philosophical arc of kind of establishing Platonism in mathematics and understanding the the role of the mind relative to sort of the Platonic character of mathematics and so on. And the things that he did were sort of technical things, sort of glued to this backbone of a kind of philosophical arc. And I think that that's it's a different thing in different people work in different ways in that regard. I mean, I guess I'm much more of the grand intellectual arc. There are lots of things I've worked on for close to half a century now that are kind of represent kind of an arc of going to a certain place. Sometimes it's not clear, in the long view of history. Both directions can be very successful. The thing that one doesn't want to do is sort of have the grand intellectual arc, but never make any progress on it. I mean, I'm trying to think of, unfortunately, there are probably not as many examples that one can kind of identify of that than one might, because they really didn't get very far. I mean, I could mention Gottfried Leibniz, for example, from the 1600s, who had this kind of vision from his earlier days of the idea that one could sort of somehow you could formalize human thought using logic, using mathematics, using that somehow human thought was formalizable. Well, and even he made a brass, a mechanical calculator, a brass, and so on. Everything that was about sort of formalizing human thought. And he did manage to make, he made particular kinds of progress in his philosophy, maybe in his work on calculus and so on. But in a sense, that arc, he was a few hundred years too early for that arc to really play out. And I think that, he kind of worked that way. By the way, in terms of humor versus not, whimsy versus not, Leibniz, for all his writings, seems like the world's most serious person. But I was looking at his archive a number of years ago now, and in his archive there are all these little sort of cartoons that he drew in the margin of his calculations and things like this, which are definitely show a certain element of whimsy. And I know that he was most of his life he was kind of a courtier, and he would entertain people at court with his funny things to say and so on. So even though none of that, I think, is reflected in his writings and the philosophy and so on that has come down for it. So I'm trying to think about this idea. Well, the people I knew, somebody mentioned the Institute for Advanced Study in Princeton. I worked there for a number of years, and I knew lots of people there. There were mathematicians I knew there who fell into these different camps. Like one mathematician who I did not personally know well, this person called Bob Langlands, who has this whole sort of giant program of associating different areas of mathematics with each other. That's an example of a sort of a big program approach. Whereas the other mathematician I knew pretty well was Jack Milner, who was a very, very successful mathematician in many different dimensions, but who is definitely sort of a take the next hill, largely a take the next hill kind of mathematician. The thing that always used to crack me up with Jack Milner was, I'd ask him some question about something about math, and he'd say, "No, I don't know anything about that." So then I would go and find the literature, and I would find out that actually Jack Milner, had been the person who figured out some key thing about the question that I'd been asking. So I would show him this thing, said, "Oh yes, I remember that now." So I always used to quip that he's the person who has forgotten more mathematics than almost anybody else has ever known. But two examples. I will have to tell a story about Bob Langlands, a person who was I guess a student of mine and subsequently worked as kind of a computer systems person around the Institute, was getting Bob Langlands up to speed in using Mathematica, what's now Wolfram language. And Bob Langlands had really never used a computer before. And so I'm told, at least. And apparently he kind of asked this ex-student of mine, he sort of developed this theory for how computers must work inside based on how Wolfram language works and how it does these transformations for symbolic expressions and so on. And he developed this whole sort of mythology of how computers must work, which is a really good idea for how computers might work, just doesn't happen to be the way they actually work. And so I found that very charming. It's kind of the mathematical theory of how computers should work, which I don't disagree with, because it's sort of aligns with the kind of thinking that I've tried to follow in building these systems I built for the last 45 years or so. Let's see. There's a comment from G. Some people are better at naming conventions than others. Yeah. People invent. I mean, I've invented a bunch of names for things, some of which I've invented in a second, and they turned out to be really good, and some of which I worked on for months, and they turned out to be not so good. I think it's always a challenge. Like for Murray Gell-Mann, for example, it was sort of an irony, because Murray was a great student of languages, human languages, and I think his father had been a teacher of languages, and Murray had sort of adopted that erudition about languages. I mean, Murray was also a person, one of the things that was probably one of his less convincing features was he would meet somebody and he would try and tell them in a very erudite way the origin and often correct pronunciation of their name. Well, this is kind of a losing proposition. And and he would regularly tell people, meet them and tell them something about their name. If there's one thing people are likely to know about and to know the history of, it's their own name. And so Murray would very often get it horribly wrong, and then he would be very embarrassed, because he was actually a quite sort of kind of a fragile ego in that respect. And I remember a friend of mine named Nathan Isgoer, who Murray had some whole theory about Nathan's last name. And Nathan said, no, Murray, some immigration official on Ellis Island made up that name from some unpronounceable Russian name or some such other thing. So, but it was a thing that wounded Murray to be wrong about something like that. And so it was kind of strange that he would sort of set himself up for a for failure in that way. I am reminded, I hadn't thought about this in forever. I remember having lunch with Dick Feynman, oh God, ages and ages ago. And for some reason, he gave me the piece of advice. If you're dealing with a woman, never tell her a joke about her own name. She will have heard it before. Okay, that was, I don't know. It's probably true of I don't think that's a gender specific thing. I do have to say, maybe to set a historical record straight about something, I remember this must have been, I don't know, 1980, 81, something like this. A British filmmaker had made a documentary about Dick Feynman. I think it's called something like The Pleasure of Finding Things Out. It's a nice documentary. That same person was going to make a documentary about me, which went off the rails, but that's a different story. Anyway, much later, 25 years later, was no more than 25 years later, was going to do something about me, which sort of went off the rails. But in any case, made this documentary, and it was shown on the BBC in England. And I guess one day it was sort of being prepped to be shown on PBS or something in the US. And Feynman says to me, runs into me in the hallway and says, hey, can you come watch this video with me? It's been shown on the BBC and it's going to be shown in the US. And, something, you grew up in the UK and you're now in the US, and maybe something about sort of the cultural differences or not between these places. Come watch this with me. Okay, so I watched this with him, and it was kind of a, it was a good video. And there's this one moment in the video where he's asked something about his children. He has 2 kids, a son and a daughter. And so he kind of explains in this video, oh, my son was interested in science and so on. My daughter wasn't really interested in science. And so he kind of turns to me and he says, does that sound like kind of a negative comment about, I forget how he put it, but basically about women in science? And I'm like, I don't think so. You know, it seemed like just a factual thing. You have two kids and they're different. Well, naive me. I mean, I guess I never really, I wasn't at all attuned to those issues. I mean, I guess my mother was a professor, and so I kind of didn't really see the you know, gender roles of professoring or not was something that wasn't particularly a thing I was aware of. So I'm like, yeah, you know, it seems reasonable to me. Years later, a woman I know, physicist, was involved in kind of picketing some thing that Dick Feynman was doing, or some event about him, I don't remember which. And sort of piece of evidence number one for kind of his view about kind of women in science was this particular comment in this particular video. And I'm like, no, I promise you that wasn't what he had in mind, because, you know, I specifically had this interaction in which in which it was clear that, you know, he was concerned that people might read it as that, but that wasn't what he had in mind. I mean, at the time when, you know, realistically, in those days, the fraction of women in physics, for example, was incredibly small. I mean, for whatever bad reason, that just was the way it was. And in most countries, in the US, for example, I know in those days, I remember in Hungary, I think the percentages were absolutely reversed, or at least people said that. So it wasn't a worldwide phenomenon. It was a US phenomenon whose origins you know, one can speculate about. But yeah, that was one of those things. But in terms of the naming of things, I'm trying to think. I mean, Dick Feynman had for what turned out to be quarks, Dick Feynman had this name partons, parts of protons and things. And Murray always used to refer to them as put-ons, just as a way of kind of tweaking Dick Feynman. And so, you know, that this was the competition between these two. I mean, in terms of naming, I have to say about those two, I remember Murray had invented this thing called the psi, that he called the psi function, a thing in quantum field theory. And I remember talking to him at one point about a thing called the beta function, which was equivalent to the psi function, and but which was the name that had become much more popular. And so I'm having this whole conversation about the beta function, and Murray is kind of looking more and more puzzled. And eventually, you know, it gets too silly. And he says, oh, you mean G times the psi function or something? And I'm like, you know, I kind of like, yes, but kind of, I'm thinking to myself, look, Murray, you knew that from the first thing I said here. You were just making this whole kind of production to make the point about your psi function, so to speak. You know, I'm trying to think about people who have named things. It's let me see. I think of lots of things I've named, and I'm trying to think of things that you know, there are cases where people have kind of notation for things. Alan Turing was quite into notation. I mean, anybody who's interested in the formalizing of things is going to be into notation. Leibniz was very into notation. You know, Leibniz was sending letters to people saying, "Don't use an X sign for you know, for multiplication. It'll get confused with X's." Of course, he didn't win on that one. And then he said about himself, you know, this notation dy by dx for derivatives is going to be confusing. People are going to think of canceling the d's, which is kind of a bane of calculus education ever since. he knew there was going to be that issue, but he thought it was, he didn't quite see an alternative to it at the time. So we sort of stuck with that issue for 300 years. But Turing, for example, in his first paper in 1936 on universal machines, had, he had a very, it's sort of a, he had to invent a very new kind of notation because it was essentially a notation for programs, and that hadn't been a thing that had existed before. And he was he used sort of the Roman alphabet, the English alphabet, whatever. And then he said, well, he'll use the Greek alphabet as well. And then because he needs more symbols, he'll also use the German alphabet, by which he meant Gothic characters. And in the end, the things he created are just in this most absolutely unreadable kind of notation that turned out to be full of bugs. He hadn't had sort of the idea of bugs, so he didn't go looking for them in his universal machine at that time. I mean, I think this idea of, can you have a clear notation for things is something that, well, some people have been good at that. And in modern times, we kind of have an industrial version of that in sort of trying to design computational language. But there've been kind of the upticks and the downticks in doing that. I'm trying to think about other names. Let's see, there are so many names in science. I probably, for almost any name, I can I remember the origin of it. I mean, in some places, there are very erudite kind of Latin and Greek names. Oh, I don't know, Cybernetics, which has given us cyberspace and cybersecurity and cyber everything. I mean, that comes from, I guess in Latin, it's gubernator, the helmsman of a ship, sort of the control of a ship. I don't know exactly who came up with that. I don't think it was Norbert Wiener who really used it, but I think it was before that. But that just turned into a pretty nice word. Then there are other kind of classical terms. Actually, Murray Gell-Mann, back to Murray again, was always a stickler for, is that the right name for something? Okay, one thing that I was disappointed by, when I was first working on cellular automata, I was studying them from a very different point of view than people had done before, and very different details of the way I set the system up, like in 1 dimension versus 2 and so on. And I really wanted to give them a different name because I thought cellular automata wasn't a particularly good name. And so I asked Murray, and I had this one name that I'd considered, which was polymones, kind of a nod to Leibniz's monads in the poly, the many, Greek for many version of that. And Murray was very negative about that name and just sort of said, oh, it sounds moany and, whatever. But it's like, Murray, so give me a way of thinking of names. You've thought of quarks, you thought of strangeness. I think he came up with the QCD name. How do you think about names? And he never had anything useful to say about that, which was disappointing. I will say that Steve Jobs, many years later, was, I was sort of agonizing about the name for Mathematica, and had Mathematica was at first called Omega, which led to the amusing phenomenon that from 1986 to 2009, when we brought out Wolfram Alpha, we had gone from sort of Omega to Alpha. In the early days of Mathematica and Wolfram language, it went through, its first name was Omega, its second name was Polymath, its third name was Technique, and its final name was Mathematica, which actually Steve Jobs had sort of semi-independently suggested. And I had kind of rejected on the grounds that it was too long and too ponderous. And I sort of was concerned about its alignment with math, even though I believed that was our first sort of killer app for what we were building. But Steve gave me this kind of his heuristic, or his version, his theory of coming up with names for things, which was to come up with sort of the generic term for something and then romanticize it. And at that time, he was a big fan of Sony, the company, and they had this product called the Trinitron, which was a kind of television tube, which in those days had 3 different electron guns for the, I think so at least, for the 3 lighting up different phosphor dots on the screen to produce red, green, and blue. And his point was it sort of starts from 3, and then it's kind of romanticized from 3. And that was his kind of theory of naming. But I never got from Murray, I never got a theory of naming. And let's see, did I ever talk to, did I ever have to name things? Well, with Dick Feynman, yeah, I suppose there was some naming, because I was working on kind of language and designing SMP and function names in SMP. And I would say that I don't think Feynman was always, I think, pushing to name things in a way that was his way of thinking about it at that moment, which was, I was like, that's just not going to work, because yes, you come to it, and the way your mind is set up today, that's how you think of this concept. But tomorrow you will have forgotten that way of thinking about it, and it will be then incomprehensible when you hear that name. And one criterion I have for names we use in Wolfram language is, if you hear the name, you should have some idea what it is without having in your mind some whole context of the way that name was thought about. There's a question here about Heinz von Forster. I never met Heinz von Forster, unfortunately. He worked at Illinois, actually, a few years before I was there. I never met him. I sort of should have done. I mean, there was a whole crowd of the kind of the old line cyberneticists who had kind of descended from Wiener and to some extent from Warren McCulloch. They, there were people like Herman Harken, Manfred Eigen. These are people I certainly met who were in the early stages of that. There was a person called von Bertalanffy, who I never met. Let's see, there were a bunch of others in that crowd. Oh my, how can I not be remembering them all? It was a very, cybernetics had been a big push in the 1950s. It was kind of like, and now we're going to figure out how brains work, and animals too, and we're going to make robots that sort of work the same way, and it's all going to come together right there in the 1950s, and it didn't. And that was sort of, there was a big push on those things, and the sort of cybernetics movement, which was very tied into the big thing of the time. Psychiatry was very big at the time, and those things got really, sort of connected together. And it was kind of like, we're going to solve brains and control and all that kind of thing in those times. And it didn't really happen, or didn't happen. And there was branches that developed. There was sort of the AI branch that for a brief while went in the neural nets direction, but that kind of died out. And instead it went in the direction of, let's kind of solve minds in a mathematical kind of way, and or a way that's sort of a programs kind of way. Let's figure out the programs for the mind, so to speak. And that was the way that AI progressed for a long time, with sort of in the early 1980s, there was kind of the notion of expert systems, which were kind of make rules for how to think about things, and that will be the way to do things. And then in a different direction from the early cybernetics came control theory, very practical mathematical theory for getting thermostats that work, or autopilots that work, and so on. Just a very kind of an actual sort of practical mathematical theory that really didn't address the deeper questions. I do have to say, and maybe I've talked about this before, but expert systems remind me of a piece of my history, which was my first company, which I started in 1981. At the time, I called it Computer Mathematics Corporation. I was then a young'un who thought I was, physics professor type, and who am I to kind of run companies? And so I kind of brought in people to run that company, which turned out to be a mistake in the end. But that company, by 1982 or 3, had kind of attached itself to some other pieces, and the whole thing was calling itself Inference Corporation. which is a very modern name in the time of AI, when everybody has, is talking about doing inference with LLMs and all this kind of thing. And that's the, there's the training phase and there's the inference phase where you're actually running the LLM. Well, I had this company called Inference Corporation back in 1982. Although that name, I think, was very liked by the venture capitalists who got involved, who were at the time saying, AI is the thing. AI is going to be the great thing of the ... 1980s. I was reminded of this because the company went public 30 years ago. Well, it must be right around now, actually. But it filed for its public offering 30 years ago, a few weeks ago, in 1995. And by that point, I had not been associated with the company in any serious way for quite a long time. But and I was sort of not hopeful about its prospects. And it seemed to be just keeping on raising rounds of financing to sort of keep the company going. And the people who were running it seemed to be quite good at raising money, but it wasn't clear they were any good at making money. But I was, so finally I get this pile of papers and I figure, okay, the company finally didn't make it, it's bankruptcy filing. But no, I opened the envelope, and actually it was an S1, it was the public offering documents for the company. So that was fun and exciting. But at the time, I was in the middle of working on my big book, New Kind of Science, and I was busy with my own current company, Wolfram Research, and so on. And I just didn't pay any attention to this. And I was like, okay, I still own a chunk of this company, and yeah, let me sell it. And I don't really believe in its future prospects, so let me just sell it and be out of there type thing. And I realized that I literally never opened the S1 document back in those days. I never kind of saw the pitch for the company going public. And I finally opened it a few weeks ago. And I was kind of surprised because, well, I had sometimes made the joke that the company had run out of letters of the alphabet in rounds of financing. Actually, they got to Series I, which is, people talk about Series A, Series B, Series C. Sometimes they get as far as Series D. But Series I is almost unprecedented. It's didn't get to Z quite, but there was a bit of an exaggeration, but it did get a long way in rounds of financing. And I was also actually surprised to discover that the company, by the time it went public, was actually smaller than my company had become at that time, which I had no idea about. I'd kind of assumed that, it was buzzing with investors and business people and so on, that company would have been much bigger than my company had gotten by that point. But I didn't know that until until a few weeks ago. But that was I was reminded of kind of the what happened to expert systems and cybernetics and so on. So okay, well, I should probably wrap up here because I have to go back to my day job. And I think some people had suggested that I should do some live streams that are really claim nothing more than to be kind of story time, of sort of telling stories that I know, so to speak. And so I'm interested, people are interested in that. I suppose I certainly know an awful lot of stories about my own life and the things that have happened in it, some of which I think are kind of interesting. I think, I've had the good fortune to have an interesting life. Some of them are pretty funny, I would say, of sort of crazy things that have happened. It will be helpful to know if people are interested in that. Maybe I should try and do a sort of a pass of stories of my life type thing. And perhaps it's hard to know whether to, I think there's a certain amount that is sort of can be told somewhat sequentially, if I can remember it. I'm always struck, I have a decent memory, I think, but I'm also a meticulous archiver of material, or at least I've become that way in the last, I don't know, 40 years or so. And that means that I can really check my memories. And I think the thing that I find always is I remember the big parts, but there are many, many details that are often quite interesting that I forgot. And for that, I actually have to go back to actual documents and actual things that happen. I mean, I suppose one of the things that is both sort of a feature of getting lots of stuff done, lots of things happening, is it's harder to remember what happened. I mean, I've noticed in recent times, I've been lucky enough to be able to be making quite a lot of progress, particularly in science and also in technology. But it's starting to be the case that I write lots of things in science, and I'm really forgetting. You know, I write them, and I can write them quickly enough that, you know, I built the tools to be able to figure these things out quickly and write about them quickly. And sort of the downer is that you know, I realize, oh my gosh, I don't remember what I wrote, you know, in even quite recently, and that's sort of disappointing, because things that I did earlier in my life, I sort of agonized for much longer about them, and I had much fewer tools, and was much less efficient at doing these things, and so that's kind of the good news is I'm more efficient. Things happen more quickly. More can happen. The bad news is I don't get to kind of exist in those in those activities. I'm sort of reminded a person who was actually the founder of the project management group at our company, still with the company, although semi-retired now, many years ago. Anyway, he's a person of a very, I would say, an interesting observer of life, that perhaps, you know, able to do things like dispassionately figure out, you know, how long will it really take to finish this project, which is a complex kind of dispassionate activity to work that out when it's a creative project. But anyway, I remember him saying to me at some point when I was kind of rushing to when I was sort of complaining that was working on my new kind of science book, and I'm like, I need to get it done. I need to get it done. It took 10 years in the end. And it was saying to me, you know, you should, you know, you should sort of relish the journey, so to speak. And he was partly right. I mean, I think I like getting to the end, but there is something to be said for sort of experiencing the journey more deeply. And if you go too fast, you forget it. All right, enough said about that. Time for me to go back to my day job, and so maybe I will try some story time adventures at some point with these live streams. But for now, well, thanks for joining me today, and bye for now.